In this video, we're going to look at some problems involving L'Hopital's rule, particularly when you start off with a product that you have to rewrite. So, first one we're going to look at is limit as x goes to 0 of x times cotangent x. So clearly x goes to 0. Cotangent of x at 0 has cotangent has a vertical asymptote, so this is a 0 times infinity case. So it needs to be rewritten before we start taking any derivatives. So the limit as x goes to 0 of, let's rewrite it as x over, I'm going to put this in the bottom, which would be 1 over cotangent x or tangent x. Because tangent of 0 is 0, so I now have my 0 over 0 case. So now my 0 over 0 case, I can apply L'Hopital's rule. And I've got the limit as x goes to 0. Derivative of x is 1. Derivative of tangent is secant squared x. Secant squared of 1. Well, if you input 1, you're going to get 1 back. So 1 squared, or 1. So you get 1 over 1, or 1. That one wasn't too bad. It's just seeing how to rewrite it. Let's take a look at one that gets a little bit messy. So we're going to do the limit as x goes to 0 of ln of x times sine of x. Let's say we're going to the 0 as the right to keep it defined. Ln of x is asymptotic there, so it's going to go to infinity. This is 0, so we've got an infinity times 0 case. So we're going to want to rewrite this so that we have 0 over 0 or infinity over infinity. Whenever possible, I like to try and leave ln of x on top. So I'm going to put 1 over sine x in the denominator. We'll remember 1 over sine x is cosecant x. Now I've got my infinity over infinity case. So I'm going to do my L'Hopital's, and I'm going to take the limit as x goes to 0 from the right. Derivative of ln of x is 1 over x. Derivative of cosecant x is an interesting one. If you remember it, it's negative cosecant x cotangent x. And before we do any more work, we're going to want to try and rewrite this. So I've got 1 over x on top. The denominator, well, let's deal with this thing in terms of sines and cosines before we do anything. Cosecant is 1 over sine x. Cotangent is cosine x over sine x. So I see I'm going to get a cosine x over sine squared x. Oh, and I should have written limit. We are still taking the limit as x goes to 0 from the right. And what I'm going to have sine squared x all over x cosine x. And it will be negative. What I did is multiplied these two together and then flipped and multiplied. Now if I look at where it's going from the 0 to the right, I got a 0 over 0 case. It qualifies for another L'Hopital's rule. So we're going to need to calculate the limit again as x goes to 0 from the right. Calculating it on top, we'll just leave the negative up front for right now. I have 2 sine x cosine x all over. Here I've got a product rule. So I've got x times the derivative of cosine, which is negative sine x, plus cosine x times the derivative of x, which is 1. Now we're going to see if we can plug 0 in. If I plug 0 in, because of this right here, top is 0. This 0 times 0 plus 1. So this actually becomes 0 over 1 or 0. So we were actually able to calculate that limit. It took a couple times L'Hopital's rule, and we needed our derivatives of trig functions.